Hello, my dear students. Welcome back to the session. This is Sudhakar Reddy. So, in this session, we are going to discuss some more important questions. That means these questions are given in the grand test papers, which was given by experts, subject experts. Okay, so let us discuss those questions today. So, today's first question is like this: the number of ways of choosing, the number of ways of choosing choosing 10 objects 10 objects out of 31 objects out of 31 objects out of 31 objects of which 10 are identical of which 10 are identical 10 are identical and remaining are distinct and remaining are distinct remaining are distinct remaining are distinct. If you read the question carefully, it's so easy question. Let us see the solution. Here how many objects we have? So we have 31 objects I have. Out of 31 objects, 10 are identical. So how many identical objects are there? Identical objects. Identical 10. Out of 31, 10 are identical. Then how many remaining? How many are distinct? So distinct objects are 21. Right? Total 31. Now, from the 31 objects, you have to choose 10 objects. You have to choose 10 objects. The 10 objects may be identical or distinct. Some are identical, some are distinct. All are identical, all are distinct. Okay. So, let us see the different cases. So, now, if all the 10 objects are identical, so how do you select 10 identical objects from 10 identical objects? In how many ways you can select 10 identical objects from these 10 identical objects? One way. R means plus R. I am going to select 9 identical objects and one different. In how many ways you can select 9 identical objects from 10 identical objects? One way. And you have to select remaining one object from this 21. So in how many ways you can select one objects from 21 objects? 21 C1, 21 C1, R. You can select 8 identical objects and 2 distinct objects. In how many ways you can select 8 identical objects from 10 identical objects? One way. That is one way, there is no change. So and remaining 2 objects can be chosen from 21 distinct objects. In how many ways you can select 2 objects from 21 distinct objects? 21 C2. In a similar way, 10 are identical objects. 8 are identical objects. One is distinct. 8 are identical. 2 are different. Next, 7 are identical. 3 are different. 6 are identical. 4 are different. And so on. All are distinct. Means 21 C10. 21 C10. So this is 1. So 1 can be written as, can I write 1 is 21 C0 plus 21 C1 plus 21 C2 plus 21 C3 plus and so on plus 21 C10. 21 C10. So in binomial theorem there is a result NC0 plus NC1 plus NC2 plus and so on up to NCN. NC0 plus NC1 plus NC2 plus and so on plus NCN is equals to 2 to the power of n. 2 to the power of n. Suppose here 21C0 plus 21C1 plus 21C2 plus and so on 21C21. The question is like this. Then the result of this one is 2 to the power of 21. 2 to the power of 21. But here 21C0 up to 21C10 is that. That means 21C0 to 21C1 means how many terms? How many terms? How many terms? 22 terms. 22 terms. Yeah. 21C0 to 21C10 means how many terms? 11 terms. So this result is half of it. This result is half of it. So the value of this one is half of 2 to the power of 21. So the answer for this question is 2 to the power of 20. The answer for this question is 2 to the power of 20. This is the explanation. For this question, you should remember this result. This is a standard result in binomial theorem. Clear? Okay. The next question is like this. Consider a circle. Consider a circle. Consider a circle. X square plus y square is equal to 1. And point P1 comma root 3. And point P1 comma root 3. And point P1 comma root 3. PAB is a secant drawn from PAB is a secant drawn from P intersecting circle at capital A and capital B. Capital A and capital B. Then range of modulus of PA plus modulus of PB. Range of modulus of PA plus modulus of PB. Achha. It's a very good question. What is the circle? Generally, the circle is denoted by the letter S. S is x square plus y square minus 1 is equals to 0. So this means the circle may be like this. This is the circle. And the point P is equals to 1 comma root 3. 1 comma root 3. Of course, the center of the circle is 0 comma 0. And radius is equal to 1. The center of the circle is 0 comma 0. And the radius is equal to 1. Okay. Yeah, PAB is a secant drawn from PHR. If we substitute P in this circle, what will happen? So 1 plus 3 minus 1 is 3. So that means the value of S11 is greater than 0. Clearly, the point lies outside of the circle. So clearly the point lies outside of the circle. Let us say this is the point P. From P, a secant is drawn. This is the secant. Let us assume this is the secant. The secant intersect the circle at capital A and capital B. Capital A and capital B. From an external point, a secant is drawn. That secant intersect the circle at capital A and capital B. Then we have a famous result, that is PA into PB is equal to S11. PA into PB is equal to S11. So PA into PB is equals to PA into PB. S11 means you have to substitute this point in this circle, that is 3. What is the value of PA into PB? 3. So y has gone modulus there, PA, modulus of PA plus modulus of P. That means modulus of PA means distance. It never be negative. So we have one result. We know that PA plus PB by 2 is greater than or equals to square root of PA into PB. by am greater than or equal to gm. PA plus PB by 2 is greater than or equal to square root of PA into PB. So therefore, PA plus PB by 2 is greater than or equals to square root of what is the value of PA into PB is root 3. So therefore, PA plus PB is greater than or equals to 2 root 3. That means the minimum value of PA plus PB is 2 root 3. The value of PA plus PB starts with 2 root 3. And what will be the maximum value of PA plus PB? So the maximum value of PA plus PB obtained when this line passing through the center of the circle. This is the maximum distance. This line, if this line passing through the center of the circle, then that will be the maximum distance, no doubt about it. So if this secant passing through the center, then PA plus PB have maximum value. So now PA plus PB, right? So this is radius now, that is radius. Now can I write PA as CP minus R? PA distance. This PA is nothing but CP minus R, right? So PA is nothing but CP minus R plus, how do you write PB? PB is nothing but CP plus R. So PA is minimum distance, PB is maximum distance. Minimum distance is always CP minus R and the maximum distance is always equal to CP plus R. Of course, here minus R plus R gets cancels. So PA plus PB is equals to 2CP. PA plus PB is equal to 2CP. CP means distance between the center and the point. So therefore, PA plus PB is equals to twice distance between C and T is square root of 1 square plus root 3 whole square is 1 plus 3, 2. So PA plus PB is equals to 4. So PA plus PB is maximum and it is passing through center. So this is the maximum value of PA plus PB, and of course PA plus PB is greater than or equal to 2 root 3 now. So PA plus PB minimum value is 2 root 3 and PA plus PB maximum value is 4. So the range is nothing but extreme values now. So the range of PA plus PB is equals to minimum value is 2 root 3 and the maximum value is 4. So this is the perfect answer for this question. The range of PA plus PB under modulus is a closed interval of 2 root 3 comma 4. Isn't it? Okay. Right. The next question is like this. 2 unit squares are chosen at random from a standard chessboard. From a standard chessboard. What is the probability that? What is the probability that the two squares have exactly one corner in common. Exactly one corner in common. Two unit squares are chosen at random from a standard chessboard. 1, 2, 3, 4, 5, 6, 7, 8, 9 of course. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, the standard chessboard is like this. The standard chessboard is like this. Right. So, if you select these two squares, this is first square and this is second square. If you select these two squares, so there is one corner in common, this is one corner in common. Or if you select these two squares, like this, if you select these two squares and there exists another corner in common, so this is one corner and this is one corner. Or if you select these two squares, this is one corner in common. If you select these two squares, one corner in common. If you select these two squares, one corner in common. If we select these two squares, one corner in common. Corner, this is the corner, this is the corner, this is only one corner, exactly one corner in common. So, only one corner in common. If you select these two squares, one corner in common. If you select these two squares, one corner in common, one corner, one corner, one common. And how many ways you can select? 1, 2, 3, 4, 5, 6, 7. Right. So, like this, 1, 2, 3, 4, 5, 6, 3. 1, 2, 3, 4, 5, 6, 7. So 7 into 7 ways. 7 into 7 ways. Right. So if we select in a diagonal is 1, 2, 3, 4, 5, 6, 7. Like the 7 ways. So 1, 2, 3, 4, 5, 6, 7. Then there are another 7 ways. 7 into 7 ways. So total number of ways of selecting two unit squares such that exactly one corner in common is 49 plus 49. So 49 plus 49 is equal to. This is n of e. N of e. Now n of s, number of elements in sample space. Total number of squares are 64. So 64. How many squares are you can select? 64 C2. In how many ways you can select? 2 squares out of 64 squares? 64 C2. So probability of that particular event is 98 by 64 C2. 98 by 64 C2. Like this, you can discuss this question. It's a simple question. Okay. The next question is like this. Important question from inverse trigonometric function. If x is equal to tan inverse of tan of minus 6, tan of minus 6, y is equal to cot inverse of cot 4, y is equal to cot 4. Then he is asking the value of 2x plus 3y is equal to how much? He is asking the value of 2x plus 3y. So very important concept. Listen carefully. So x is equals to tan inverse of tan of minus 6 he has given. Tan of minus 6. So x is equals to, apply the concepts step by step, tan inverse of. First of all, it is of the form tan of minus theta minus tan theta. So tan of minus 6 minus tan 6 minus tan 6. Again, it is of the form tan inverse of minus 6. Tan inverse of minus 6 minus tan inverse x. So x is equal to minus tan inverse of tan 6. Tan inverse of tan 6. So tan inverse of tan theta is equals to theta for all theta belongs to open interval of minus pi by 2 comma plus pi by 2. When this theta lies in between minus pi by 2 to plus pi by 2, then only tan inverse of tan theta is equals to theta, otherwise it is not theta. So now what is 6? 6 means here 6 radians. 6 means here 6 radians. 6 radians is equal to exactly, not approximately, 1 radian is equals to 53 radians, 52 point something, let us say 52. 1 radian is equals to 52 degrees approximately. Okay. So 6 radians is equal to 16 to 52. 16 to 52 means it is 312 degrees. 312 degrees. 312 degrees. Okay. So we put it as 2 pi minus 6 radians if I write like this. If I write like this, pi minus 6 radians first. Pi minus 6. Pi minus 6. Pi means 180. 180 minus 312. 180 minus 312 is more than 90, no doubt about it. More than minus 90. So, if you write pi minus 6, this is not belongs to the principal domain of tan, that is minus pi by 2 to pi by 2. The value of pi minus 6 does not lie between minus 90 to plus 90. Suppose let us say pi plus 6. Pi plus 6. Pi means 180. 180 plus 312. It is more than 360. So, it never belongs to minus 90 to plus 90. So, you cannot write pi plus 6, pi minus 6. I can write 2 pi minus 6. 2 pi minus 6 radians. 2 pi minus 6 radians. So 2 pi means 360. 2 pi means 360. 360 minus 312. 360 minus 312 is nothing but a 48. Right? 48. 48 degrees is definitely lies in between minus 90 to plus 90. Right? So 312 degrees does not lie between minus 90 to plus 90, but 2 pi minus 6 radians is nothing but 312. 2 pi minus 312 definitely lies in between minus 90 to plus 90. But is tan 6 radians is equal to tan 2 pi minus 6? Is both are equal? No. Tan 2 pi minus 6 is minus tan 6. Minus tan 6. Tan 2 pi minus 6 is nothing but minus tan 6. Oh, so I can write simply here without wasting one more step. So tan inverse of minus tan 6. So tan 2 pi minus 6. Tan 2 pi minus 6. It is minus tan 6. So minus tan 6 is equal to tan. Why? Because it is of the form 2 pi minus theta. 2 pi minus theta belongs to fourth quadrant. In fourth quadrant, tan negative. So here tan inverse of this entire minus tan 6 can be written as tan 2 pi minus 6. Tan 2 pi minus 6. Right. So though that 6 radians does not lie between minus pi by 2 to plus pi by 2, but 2 pi minus 6 lies in between minus pi by 2 to plus pi by 2. Why? Because 2 pi means 360, 6 radians means 312, so 360 minus 312 is 48. 48 is definitely lies between minus 90 to plus 90. So this is 2 pi minus 6 in the principal domain of tan. So therefore tan inverse of tan theta equals to theta. So x is equal to 2 pi minus 6. X is equal to 2 pi minus 6. Right. So now let us take y. Y is equal to cot inverse of cot 4. Cot inverse of cot 4. So if you want to do this question, you should know the principal domain of cot. The principal domain of cot is open interval of 0 to pi. The principal domain of cot is open interval of 0 to pi. Now, here 4 means 4 radians. 4 radians is nothing but 4 into 52. 4 into 52, it is 208 degrees. Not exactly, approximately 208 degrees. Definitely 208 degrees does not lie between. 208 degrees does not lie between 0 to 180. It is more than 180. Now, see, pi minus 4 degrees. You have to start with pi, not pi by 2. If you write pi by 2, then function changes. Cot will become tan. So don't write multiples of pi by 2. Add multiples of pi by 2. Pi minus 4 degrees. Pi means 180. Pi means 180. Minus 4 degrees. Minus 4 degrees. 180 minus 4 degrees. 180 minus 4 degrees. So 180 minus 4 radians. 180 minus 208. 180 minus 208 is negative value. So it does not lie between. It does not lie between principal domain of cot. Principal domain of cot is 0 to 180. If you write pi minus 208, if you write pi minus 208, it is not belongs to for the 208 degrees. So if you write 2 pi minus 4 degrees, 2 pi minus 4 radians, 2 pi minus 4 radians, 2 pi means 360. 360 minus 208, 360 minus 208, 360 minus 208 is nothing but obviously 152. 152. So definitely 152 is lies in the principal domain of cot. 152 lies in the principal domain of cot. 152 lies in 0 to pi. So therefore 2 pi minus 4 radians lies in between. 2 pi minus 4 radians lies in between principal domain of cot. Not pi minus 4. Not pi minus 4. So cot 4 is equals to cot 2 pi minus 4. Is it correct? Cot 4 is equals to cot 2 pi minus 4. It's not correct. It's not correct. Why? Because cot 4 is equal to cot 2 pi minus 4. 2 pi minus 4 belongs to fourth quadrant. Fourth quadrant cot is negative. So this is wrong. So can I write like this? 4 minus 2 pi. 4 minus 2 pi. Cot of 4 minus 2 pi is cot 4. Why sir? Why sir? If you simplify, what will happen? Cot of take minus cot of 2 pi minus 4. If you take minus 1, cot of minus of 2 pi minus 4. Cot of minus theta minus cot theta. So minus cot 2 pi minus 4. Now cot 2 pi minus 4. It is minus cot 4. Minus into minus plus. So cot 4 is equal to cot 4 minus 2 pi. Cot 4 is equal to cot 4 minus 2 pi. So cot inverse of. So y is equal to cot inverse of cot 4 minus 2 pi. 4 minus. Though 4 does not belongs to principal domain of 2 pi, but 4 minus 2 pi lies in the principal domain of. So y is equals to 4 minus 2 pi. Y is equals to 2. Wait. Small. Wait. See here. 4 radians means 208 degrees. 4 radians means 208 degrees. Acha. So this is 4 minus pi. Pi minus 4 radians is nothing but pi minus 208. It is negative. But 4 radians minus pi. See, you have to check like that. The small mistake is that 4 radians minus pi. 4 radians is 208. 208 minus pi. 208 minus pi is nothing but 28 degrees now. 28 degrees. Definitely 28 degrees lies in between 0 to 2 pi. Right. Acha. So 4 radians minus pi. Pi minus 4 radians does not lie between 0 to 2 pi. But 4 radians minus pi. 4 radians minus pi. 4 radians is 208. 208 minus 180. It is 28. 28 is definitely lies in between principal domain of cot. What is the principal domain of cot? 0 to pi. So 28 is definitely lies in between 0 to 180. So 4 minus pi. Oh, what is the value of cot? 4 radians minus pi. Let us see. So cot, take minus common, minus of pi minus 4 radians. Cot of minus theta minus cot theta minus cot pi minus 4 radians. So it is of the form cot 180 minus theta. 180 minus theta belongs to second quadrant. In second quadrant, cot negative. So it is cot 4 radians. So cot 4 radians is same as cot 4 radians minus pi. Acha. Okay. So here, so y is equal to cot inverse of cot 4 radians is same as 4 radians minus pi. 4 radians minus pi. But 4 radians minus pi clearly lies in the principal domain of cot. It is of the form cot inverse cot theta. It is cot. So y is equal to 4 radians minus pi. Y is equal to 4 radians minus pi. Like this, we can calculate the values of x and y. He is asking 2x plus 3y. He is asking 2x plus 3y. So 2x means 4 pi minus 12. 4 pi minus 12 plus 3y means 12 minus 3 pi. 12 minus 3 pi. Here minus 12 plus 12 gets cancels. 4 pi minus 3 pi is pi. 4 pi minus 3 pi is pi is the answer for this question. Okay. The next question is like this. That Z1 is equal to 2 plus 3. Z1 is equals to 2 plus 3i and Z2 equals to 5 minus I. 5 minus I. If the curve traced out by the locus of Z, if the curve traced out by the locus of Z, by the locus of Z, such that modulus of Z minus Z1 plus modulus of Z minus Z2 is equals to 20 is inscribed in a rectangle. Is inscribed in a rectangle. Then the area of rectangle is equals to the area of rectangle is equals to area of rectangle is equals to 100 root k. 100 root k. Then k is asking value k. So Z1 is equals to 2 plus 3i. This is called geometry of complex number. So Z1 can be represented in a point, let us say that is S2 comma 3. I am going to take Z1 as S. I am going to take Z2 as S dash. 5 minus 1. I am going to take Z as P. In general, Z can be taken as X plus IY. So that is complex number Px comma Y. So here initially Z1 can be taken as S, Z2 can be taken as S dash, and Z, the complex number Z, can be taken as X comma Y. Now the given condition is modulus of Z minus Z1 plus modulus of Z minus Z2 is equal to 20. Modulus of Z minus Z1 plus modulus of Z minus Z2 equals to 20. So modulus of Z minus Z1, what is the meaning of modulus of Z minus Z1? The meaning of modulus of Z minus Z1 is the distance between the points Z and Z1. That is the meaning of modulus of Z minus Z1. Here Z can be taken as P and Z1 can be taken as S. So this is the distance between S and P. So this is SP. And what is the meaning of Z minus Z2? The meaning of Z minus Z2 is the distance between the complex numbers Z and Z2. Here Z can be taken as P and Z2 can be taken as S dash. So SP plus S dash P is equals to 20. Should link up the concept to geometry. So SP plus S dash P is equals to 2a. This is of the form SP plus S dash P is equals to 2a. It represents an ellipse. When S dash, the distance between S dash is less than 2a. The distance between S dash is smaller than 2a. Then only it represents an ellipse. Suppose if S dash value is equal to 20, then it represents a line segment. So let us check. First, you should find out the distance S dash. Distance between these 2 points. This is 5 comma not 1. This is 5 comma minus 1. Say 5 comma minus 1. Distance between S dash, square root of 9 plus 16. It is 5. And it is 20. Definitely, it is smaller than this one. So definitely, this SP plus S dash P represents an ellipse. So this SP plus S dash P is equal to 2a. This is of the form SP plus S dash P is equal to 2a. So here 2a is equals to 20. So a is equal to 5. So a equal to 10. So if it is 2a, this distance between S and S dash are called first side. So distance between first side 2ae is equal to 5. So what is the value of 2a? 20. So 20e is equal to 5. So E is equal to 1 by 4. E is equal to 1 by 4. Achha. So now we have a famous result, B square is equal to A square into 1 minus E square. B square is equal to A square into 1 minus E square. So B square is equal to A square means 100 into 1 minus 1 by 16. So B square is equal to 100 into 15 by 16. So therefore B is equals to 10 root 15 by 4. B is equal to 10 root 15 by 4. So like this we will get the value of A and B. What is the value of A? 10. What is the value of B? 10 root 15 by 4. 10 root 15 by 4. Achha. So what is given? The locus of Z such that E is inscribed in a rectangle. So the locus of Z, so what it represents? That represents an ellipse. That represents an ellipse. Yeah, the ellipse is inscribed in a rectangle. So let us assume the ellipse may be like this. The ellipse may be like this. So the ellipse is inscribed in a rectangle like this. The ellipse is inscribed in a rectangle like this. The ellipse is inscribed in a rectangle. The ellipse is inscribed in a rectangle. So if the ellipse is inscribed in a rectangle, then the length of rectangle is nothing but length of major axis. The length of the breadth of rectangle is length of minor axis. So area of rectangle is equals to length of major axis 2a, length of minor axis 2b. Here 2a means 20. 2a means 20. So 2 into b means 10 root 15 by 4. 10 root 15 by 4. So this 4 cancels in 25 times. 5 2s are 10. 10 into 10, 100. So this is 100 root 15. 100 root 15. So the area of the rectangle is 100 root 15. So in place of k, 15 is there. So the value of k is equals to 15. That locus is inscribed in a rectangle. If the ellipse is inscribed in a rectangle, so then the length of the rectangle is equal to length of major axis. The breadth of the rectangle is equal to length of minor axis. Length of major axis is 2a. Length of minor axis is 2b. So here the k value is 15. The next question is like this. This is a previous mains question. If x is equals to square root of 1 plus 1 by 1 square plus 1 by 2 square plus 1 plus 1 by 2 square plus 1 by 3 square plus and so on, square root of 1 plus 1 by 2019 whole square plus 1 by 2020 whole square. 2020 whole square. See, here in each and every term 1 is common. 1 plus 1 plus 1 plus 1 plus. Here the second term 1 square, 2 square and so on, 2019 whole square. So that means here how many terms are there? 2019 terms are there. So when this type of questions are given, first of all try to calculate the nth term. Try to calculate the nth term. See. So if you observe clearly, the nth term may be like this: square root of 1 plus 1 by n square plus 1 by n plus 1 whole square. Isn't it? Just observe. If you write n equal to 1, definitely you will get the first term. If you write n equal to 2, 1 by 1 square, 1 by 2 square plus 1 by 3 square. If you write 2019 in place of n, 1 plus 1 by 2019 square plus 2020 whole square. So this is the nth term. This is a general term of this particular series. So just I am going to simplify this one. Tn is equals to, take the LCM. Here the LCM is n square into n plus 1 whole square. Here we will get n square into n plus 1 whole square. Plus here we will get n plus 1 whole square. Plus here n square. Right? So Tn is equals to square root of, expand the numerator, n square into n square plus 1 plus 2n plus n square plus 1 plus 2n plus n square whole by n into n plus 1, right? Take these two terms from the square root. So Tn is equals to, again open this bracket, n power 4 plus n square plus 2n, so 2n cube plus n square plus 1 plus 2n plus n square whole by n into n plus 1, right? n into n plus 1. So Tn is equals to square root of, see here now, observe, n power 4 plus n square plus 1. n power 4 plus n square plus 1. So write these three terms first, after that write the remaining terms. Plus 2n cube plus 2n cube plus 2n square plus 2n square plus 2n, isn't it? Achha. Whole by n into n plus 1. n into n plus 1. See, if you observe clearly, it is n square whole square plus n whole square plus 1 square, a square plus b square plus c square plus 2n square into n plus 2n square into 1 plus 2n to n, 2n into 1. So this entire numerator is of the form a plus b plus c whole square. So here Tn is equal to square root of n square plus n plus 1 whole square by n into n plus 1. Tn is equal to square root of n square plus n plus 1 whole square by n into n plus 1. Here I am going to write. So Tn is equals to now n square plus square and square root gets cancelled, n square plus n plus 1 by n into n plus 1. n into n plus 1. Now split into two terms. So Tn is equals to n square plus n by n into n plus 1 plus 1 by n into n plus 1. Achha. Here these two gets cancelled now. Both are same. So Tn is equal, this is 1 plus, so 1 by n into n plus 1, you can split into simple partial fractions, 1 by n minus 1 by n plus 1. 1 by n into n plus 1 can be written as 1 by n minus 1 by n plus 1. If we simplify, you will get n plus 1 minus n will get a 1 by n into n plus 1. So finally, the general term of the given series is 1 plus 1 by n minus 1 by n. That is the general term of the given series. What is the general term? 1 plus 1 by n minus 1 by n plus 1. Right. The problem is not yet completed. What is the general term? 1 plus 1 by n minus 1 by n plus 1. So what is the general term? 1 plus 1 by n minus 1 by n. Now expand the series. Here how many terms are there? 2019 terms are there. So run the same summation. So x is equal to, 1 in the place of n first. 1 plus 1 by 1 minus 1 by 2 plus, write the second term, 1 plus 1 by 2 minus 1 by 2. If you write n equal to 2, we will get the second term. If you write n equal to 3, 1 plus 1 by 3 minus 1 by 4 plus and so on plus. At last you have to write 2019 in terms of n. 1 plus 1 by 2019 minus 1 by 2020. Right. So yes, this is minus 1 by 2 plus 1 by 2 gets cancels. Minus 1 by 3 plus 1 by 3 gets cancels. Minus 1 by 4 plus 1 by 4 gets cancels. Minus 1 by 2008 plus 1 by 2019 gets cancels. If you want to cancel minus 2000 to 1 by 2020, then there will be next term. There is no next term. So minus 1 by 2020 doesn't cancel. So now x is equal to, now observe, 1 plus, in each and every term 1 is remains, 1 plus 1 plus 1 plus 1 plus and so on. Here how many terms are there? 2019 terms are there. In each and every term, what is the first term? 1. What is the first term? 1. So therefore, 2019 and one more 1 is there. Achha. So 2019 plus 1, it is 2020. 2020, and at last there is another term minus 1 by 2000. So now take this 1 by 2020, that's 1 by 2020 is equals to 2020 minus x. 2020 minus x. So 1 is equal to 2020 into 2020 minus x. Multiply with 2, 2 is equal to 4040 into 2020 minus x. So why you calculate like this, sir? He is asking this value. He is asking this value. What he is asking? He is asking about 4040 into 2020 minus x is equal to how much? So he is asking this value. The answer for this question is 2. This is the way of approach. Very important model. Very, very important model. The answer for this question is 2. The next question is like this. The digit in tens place of the digit in tens place of 7 power 14 whole power 14. 7 power 14 whole power 14. This it's a very simple question. It's a very simple question. The given one 7 power 14 whole power 14. So 7 power 14 14s are 14 14s are 14 into 14 is 196. 196. So it is 7 power 496 is of the form 4n. 496 is of the form 4n. So why you write 4 in the form of 4n, sir? Let me explain. 7 to the power of 1 is 7. 7 square is 49. 7 cube. So 7 cube means 49 into 7. 343 I think. 343. 7 power 4. 7 power 4. So 343 into 7. 7 3s are 21. 7 4s are 28. 30. 7 3s are 21. 240. 2401. What is 7 power 5? 7 power 5. So 2401 into 7. Again, the last digit 7. From the next one also, 7 power 1, 7 square, 7 cube, 7 power 4. From 7 power 5, the last digit may repeat. 7, 9, 3, 1 like this. So, here the period is 4. Here the period is 4. Okay, so right. Here if you write n equals to 1, if you write n equals to 1, it is 7 power 4. If you write n equal to 1, it is 7 power 4. So, in 7 power 4, the last two digits are 0, 1. If you write n equal to 2, if you write n equal to 2, it is 7 power 8. 7 power 8. Right. In 7 power 8, last two digits are also 0, 1. No doubt about it. No doubt about it. Because there is a period 4. Suppose if you write n equal to 3, it is 7 power 12. In 7 power 12, last two digits are 0, 1. No doubt about it. So, in 7 power 14 whole power 14, so it is of the form 7 power 4n. So, the last two digits are always 0 and 1. So, he is asking the digit in tens place, the digit in tens place is 0. Of course, if you ask the digit in ones place, that is 1. So, the digit in tens place is 0, the digit in ones place is 1. That's it, simple question. So, the next question is like this. If 9 HMs are inserted between 1 by 36 and 1 by 1296. 1 by 1296. Then he is asking, then it's an interesting question. Then the AM of the reciprocals of the third and seventh HM. is equal to. It's an interesting question. So 9 HMs are inserted between 1 by 36 and 1 by 12. So between 1 by 36 and 1 by 1296, how many HMs are inserted? H1, H2, H3, H4, H5, H6, H7, H8, H9, and the last one is 1 by 1296. Between 1 by 36 and 1 by 1296, like this, he has inserted 9 harmonic means inserted. So, if 9 harmonic means are inserted between two numbers, definitely this series is a harmonic progression, no doubt about it. Definitely it is an harmonic progression. Now, first of all, what he is asking, the AM of reciprocal of third HM. This is third HM and seventh HM. The AM of reciprocal of third HM. What is the reciprocal of third HM? 1 by H3. What is the reciprocal of third HM? Seventh HM? 1 by H1. So he is asking required. What is required? Required result 1 by H3 plus 1 by H7 by 2 is equals to how much? This is the result he is asking. AM of reciprocal of third and seventh HM. Third HM is H3 and seventh HM is H7. Reciprocal is 1 by H3 plus 1 by H7 by 2 is equal to how much? Right. So clearly this is an harmonic progression. Now convert into AP. So 36 comma 1 by H1 comma 1 by H2 1 by H3 1 by H4 1 by H5 1 by H6 1 by H7 1 by H8 1 by H9 comma 1 2 9 6 are in AP. Are in AP. Achha. So there is a speciality for AP. So in AP, the sum of the last two terms is equals to sum of the next these two terms. So in AP, 36 plus 1296 is same as 1 by H1 plus 1 by H9 is same as 1 by H2 plus 1 by H8 is same as 1 by H3 plus 1 by H7. In AP, 36 plus 1296 is same as 1 by H1 plus 1 by H9 is same as 1 by H2 plus 1 by H8 is same as 1 by H3 plus 1 by H7. All are equal. That is a property of arithmetic progression. So 36 plus 1296 is same as 1 by H1 plus 1 by H9, 1 by H2 plus 1 by H8, 1 by H3 plus 1 by H7. But what do you want? 1 by H3 plus 1 by H1. Therefore, 1 by H3 plus 1 by H7 is equal to 36 plus 1296. 36 plus 1296. He is asking 1 by 3 plus 1 by 7 by 2. So 36 plus 1296 by 2. 36 plus 1296 by 2. So this is 18. 18 plus 6, 4, 6, 4, 8. 18 plus 6, 4, 8. So 6, 5, 8, it is 6, 6, 6, 666. Achha, lucky number. 666 is the answer for this question. 666 is the answer for this. So today we discussed very important questions, very important models. So don't skip the video, please watch completely. Okay, so if you liked my explanation, please share and don't forget to subscribe and please support. Okay, so right. With this I am leaving. And tomorrow we will discuss some more important examples, important questions. Thank you. Bye bye.